so we'll just go over this one more time. So my mnemonic was excellent girl lipstick pudding. So E is for early endosomes, G is for Golgi complex, L is for late endosomes, and P is for plasma membrane. And then I just put them in order. So 3, 4, 3, 5, and PI 4, 5. So you can see how that's going, right? 3, 4, 3, 5, and 4, 5. Right? Hopefully that helps you remember the locations because those are kind of important. Another little note that I wanted to make about PIP3 here. So PIP3 is different from IP3, just make that distinction clear. And PIP3 is an important molecule because it can go about activating a protein kinase called AKT. And also remember that it gets dephosphorylated at the third position by a phosphatase called P10 and gets dephosphorylated at the fifth position by a phosphatase referred to as SHIP. Okay, so remember those 2 points about PIP3s. And then a little note about the salmonella. Salmonella enterica, PI35P2, and trafficking. Now, what this does, it produces a phosphatase, which is called SOP-B, and it's a phosphorinositide phosphatase. Okay, and what this does is it uses PI35P2 as one of its substrates and dephosphorylates it. And this PI35P2 is extremely important in endomembrane maintenance and vesicle or intracellular trafficking. So it's like a traffic police guy. Intracellular trafficking. So when this gets dephosphorylated by this phosphatase, obviously it cannot function properly, and these guys get away with it and survive, okay, in the host cell. Now we should talk a little bit about how you go from your PIP3 to diacylglycerol and IP3, alright? Inositol triphosphate, that would be IP3. So the enzyme that works here is the PLC beta, and remember this is through the GPCRs. You can have the same reaction going on through the RTKs, but they will use PLC gamma, and let me just quickly confirm that. I'm just trying to draw links here. Yes, it is. Yay! So PLC gamma. So it does the exact same reaction, but it produces these things here. Now IP3, as we all know now, are involved in calcium channel secretion. And what does diacylglycerol do? So diacylglycerol is responsible for activating protein kinase C, and protein kinase C is a serine threonine kinase, and it's an important kinase. That's all that we know. IP3 is obviously, it binds to the calcium IP3 receptors on the ER membrane, and when they bind there, they also act as channels. So there's lots of calcium in the ER lumen, and all that calcium gets diffused out when IP3 bind to these receptors. So that is an important function for IP3s. And calcium ions, as we will cover later on, and we're just looking at it right now, they bind to various target molecules involved in muscle contraction, relaxation, exocytosis, so on and so forth. Lots and lots of functions. So that finishes up our little topic on phosphorinositide kinases. Now we'll start with protein kinases, and a little bit on protein kinases, not too much, but then there's a lot of it on protein phosphatase, and then some receptor tyrosine kinase pathways. So we'll see you guys in the next video.